I tried to follow certain doctrines for her, but I can't stop being complete with her. She's now doesn't want to use shellfish either, so even for instance, farm salt, shellfish salt, no.
No food or drink other than water is allowed in the lecture hall? Sorry, is that one? No food or drink other than water is allowed. I wish I would go conference.
It's amazing.
Hey, hi.
Scott, see that one? Just try that one. Sure. Let me get back. Oh, good. Oh, thank you. It helps a lot. Good evening. Hello. Good evening. Welcome to the Explorers Club Public Lecture Series. And how many people here this is their first time? Wow. So for some background about the Explorers Club, we were founded in 1904. We were incorporated in 1905. And we are not about adventure travel. We're about science. We do field science, mainly in the field, not always in space, sometimes by robotics. But the whole idea of the club is to bring back promising and helpful science to humanity on expeditions and what we seek out. Now, just to give you an idea of some of our famous firsts, if you look up there is a sledge from Admiral Peary's famous North Pole expedition, which arrived in 1909. And Robert Peary and Matthew Henson and guide Otto, a Inuit guide, went there together with three other Inuits. Matthew Henson, you may all know, was African American, and he's since been celebrated, which I'll mention later, but he's been celebrated in a PBS film called North Pole Promise, which was on prime time and filmed by the Harvard film team. One of the other firsts is the South Pole, which we're going to be talking about in part tonight, and that happened in 1911, and Amundsen, another member of the club, was the first to go to the South Pole. Then in 1953, Sir Edmund Hillary climbed Mount Everest, was first to Mount Everest, and with his guide Sherpa Tenzing Norway, was also joined him, Norgay, I should say. And also the deepest point in the ocean, Challenger Deep, which is over 7 miles, happened in 1960. And Don Walsh and a Swiss engineer, Jacques Piccard, were first to go the deepest part of the ocean. And today, a number of our members have gone to Challenger Deep, as well as to the top of Mount Everest. Of course, then the most famed accomplishment was in 1969. Three of our members, Neil Armstrong, Buzz Aldrin, and Michael Collins, three men that I knew personally, all went on Apollo 11. And of course, that was the first lunar space landing. Now, tonight, I have the privilege to introduce two of our speakers. And this is a very important piece of work that they're working on in terms of the Thwaites Glacier. And it will impact our lives tremendously in the future as it melts. And as the ice sheets go in Greenland and Antarctica, it'll have serious consequences to humanity. Two of our speakers, one of them, Leilani Henry, is an author of The Call to Antarctica, Exploring and Protecting Earth's Coldest Continent, published in 2022. Her book, she utilizes the diaries of her late father, George W. Gibbs, Jr., who served on Admiral Richard Byrd's third expedition to Antarctica, another member of the club. She has demonstrated thought leadership, facilitator, coach in the field of organizational and leadership development, and has been widely cited in national publications. She worked with the International Thwaites Glacier collaboration on their leadership, effectiveness, and cross-cultural communication and teamwork, especially for the inclusion of diversity, equity, and accessibility. This brings to note that one of our very famed Lowell Thomas members, Dr. Alan Counter, who passed away 3 years ago, did a primetime PBS with the Harvard film team on Matthew Henson and Admiral Perry's conquering of the North Pole and reaching the North Pole. And he had something called the Harvard Foundation, and which I was very curious in reading Leilani's explanation here of communication, teamwork, and inclusion and diversity is a very similar organization that Harvard also had at one point, it still does. Our other speaker is Ted Scambos. Dr. Ted Scambos is a senior research scientist at the Earth Science Observation Center, a part Cirrus at the University of Colorado in Boulder. He specializes in using satellite data of polar ice caps to map these regions in new ways and studies to affect the climate change in Antarctica. And among his research interests are climate change impacts on polar regions, Antarctic history, geochemistry, planetary science. I'll let him say a few more things about himself when he comes up to speak. And I know this is going to be fascinating. I have a connection to this. I moderated a panel this summer with Sylvia Earle and Alex Moore, two members of the club, and I was in Newport with a great concentration of wealth that was at that conference. And we talked about 3 tipping points in the ocean, and one of them was the Gulf Stream, which was front and center, which could collapse in the near future, maybe 10 or 15 years or even sooner. And it would have catastrophic impact on humanity. The northern hemisphere would have much colder temperatures. We might even have freezing summers at times. We'd have trouble growing food. It would change the world forever if it collapses. And what our speakers are going to talk about tonight could be instrumental in causing that to happen because of the melting of the ice and the lubrication of the oceans coming under the ice sheets as the oceans come up and melt. It's a cascading tipping point of the first order. And I'll let you, Ted, fill them in on that. And go ahead. Do you want to go first? Okay, great.
Wow, thanks very much, and thanks everybody for being here tonight. Really great that some of you are first-timers to the Explorers Club. I, too, have not been to this building before. I've been a member for a few years, mostly because of the Antarctic work that I do. I've been to Antarctica 23 times, all over the continent, and so, I'm sorry, all over the continent, and I feel like I'm isolated from you back here, but have explored a lot of different aspects of Antarctica and how it's changing due to climate change. But we're going to talk mostly about Thwaites Glacier tonight, which is probably the biggest threat, the biggest unknown part of sea level rise between now and the end of this century and extending into the next century, into the 22nd century. It's going to be a major factor in terms of what happens around the oceans. But we're going to talk about a couple of stories that have a lot of different starting points. And one of them is a starting point with the word yes. And this one yes actually leads in its own way to every aspect that you're going to see tonight about Thwaites and about the work that Leilani has done and that I'm doing. This is George Gibbs, Jr., a 23-year-old man in 1939 who said, yes, I'll go to Antarctica with the Navy. on Richard Byrd's third expedition. He had the idea of going to, we could turn that out. That'd be okay with me. Down? How about that? Said yes, I'll go to Antarctica. And that led to Leilani finding his diary after he passed away. George Gibbs is Leilani's father. And George Gibbs wound up being the first African-American man to set foot on the continent. And you'll see that moment in this talk in just a little bit. So Leilani said, yes, I'll undertake the job of trying to write these notes up into a story about Antarctica. And I'll contact my friend Ted Scambos to help me figure out a few things about Antarctica. It's a wonderful summary of the science and the history of Antarctica that Leilani wrote, and a fantastic connection between the two of us. It started with being aware of the history, and it followed up with a connection on the Thwaites project because of her work on team building, and we extended that to team building in Antarctica. Well, let's go back a little bit further in time. 1774. Captain James Cook has been sailing around the Pacific, basically circumnavigating Antarctica, as well as exploring a whole lot of the southern Pacific. Eventually, he died after encountering some folks in Fiji. But before that, that happens. He got to this point here. And he said, that's it. I can't get this ship and this crew any further south. There's ice everywhere. We have been pushing and pushing and pushing. This was far further south than any other group had ever gotten it. And he's writing later on to the King of England saying, I think it was the King, yes, the King George III of England, you don't want to go back here. I don't want to go back here. This is a land that is so worthless, doomed by nature. Everlasting frigidness, his horrible and savage aspect. I mean, you could just hear him like, taking his quill pen and scratching the paper as he's writing these words down. Horrible and savage aspect, I have no words to describe. He didn't like it. So 166 years later, Richard Byrd is aware of this story, of course, and he brings his ship right to about the same spot as that big red dot there on the map. And he says, I can get to that same place with my ship, but I've got an ace up the sleeve this time. I've got a technology that certainly wasn't there in 1774. And I'm going to look for the last large undiscovered section of coastline on Earth, this whole blank area on the map here, with my crew. By the way, just to make the connection, George Gibbs is on that ship. And Leilani is going to take it from here.
Ted, I didn't actually practice advancing, so we're all right. Well, I also. Oh. Okay. All right. Hello. Well, I'm delighted to be here, and I'm glad that I have a roving mic. Today we spoke with 45 fourth graders, and we were demonstrating a crevasse and driving the Huskies on the sled, and so I've been a lot of moving already today. My first task was to transcribe this handwriting. My father wrote every day for 6 months, round trip from Boston to Little America and back. And luckily, I knew enough about his handwriting to be able to do this. There's so many stories. This story is, I met someone on a plane who introduced me to John Barrett, who introduced me to Ted Scambos. Some of you may know John Byrd. He was on Deep Freeze.
He was like
IGY, 1959. And they invited me, the American Polar Society invited me to write an article for APS. So I wrote about my father's story.
APS is the American Polar Society.
Right, thank you. And the first person who called me was Jim Richardson, who was Jack Richardson's son, who took the first colored film on the ship, the USS Bear. So he invited me without knowing who I was for the weekend in Virginia, or Maryland, I'm sorry, Maryland, near Annapolis, to dig through his father's trunks. And the first thing I saw was this photo. He hadn't even looked at his father's trunks. We found his father's diary. We found a letter from his father to my father, because Richardson stayed on the ice and my father was crew. So, I could talk forever about the synchronicities in the last 25 years. But that's all I'm going to tell you now, except for this handwriting is the diary entry when Byrd flew to over the Walgreen coast. And no one knew that Byrd was sick at the time. So he writes, the admiral gets off his sick bed because it's a beautiful day and they have to fly when the weather is good. So you won't see that anywhere else. And this I found on the internet. Well, they'll
So it's the Bear arriving at the Ross Ice Show.
I wanted them to be surprised. That's George W. Gibbs, Jr. He had the honor of being the first man off the ship. He did have some problem with racism, and it was middle management. Some of the sailors that were not the captains. And so they decided, and I found this in Herville Bryant's diary, that they talked about the fact that this would be a great thing to be able to honor Gibbs for his courage and zeal and help on the ship. He was the lowest rank on the ship, mess attendant 3, which is, of course, only blacks could be in the mess attendant area. Even no matter what your skill level was, that's what you needed to do. So he gave him the award of being the first man off the ship. And that's where he became the first black person to set foot on Antarctica. There were 2 other black men on the ship. And I know you can't see online, but for you in the room, that's George Gibbs. He doesn't really look happy, so I'm not sure what was going on. This is Littleton, one of his friends that he worked with. And I believe this is the other person. And they received a silver medal if they went 2 round trips. And one of the people, Napier, didn't want to do that, so he got a bronze medal. I also interviewed, okay, let me just go to the next one. So this is, put this down. So this is the crew list, and I'm happy to say that many of these names, I either interviewed children or I interviewed them personally before they passed away. So Johnson passed away at 102, and Kowalski wasn't quite that old, but I went to visit him. He greeted me like a long-lost friend and said I looked exactly like my father. And great sense of humor, so I know they got along well. He used to steal sandwiches off my father's tray when he was delivering food to everyone. Whoops. I want to go back. All right, so I wanted to just point out the Admiral, the Captain Cruzen, Dufek became an amazing leader. And so my father was a great leader. He brought Rochester, Minnesota, put it on the map. You've heard of the Mayo Clinic. You would have thought it was Paris, the way my father talked about Rochester, just a perfect town. Of course, nothing is perfect. But he did help other people of color adjust to coming to Minnesota and being very much in the minority. And he learned that from how he was treated by the admiral and the captain and the leaders on the ship. Okay. So Ted mentioned the technology. Some of you may know that Admiral Byrd took this U.S. cutter Bear out of a museum in California for $1. So this was his trusted ship. And the men took bets that it would not get to Antarctica, that they would sink in 5 days. My father spent the summer with Richardson, that I mentioned before, scraping the ship and getting it ready. And that's when they talked about how far they were going to get. And that's one of the scenes. Many scenes, they were stuck in the ice about 3 times. I just gave an interview with the UK Antarctic Heritage organization, and he asked me some very intriguing questions. My response was that my father, his sense of humor was, when they got stuck in the ice, the captain and the admiral were walking around wondering who they were going to eat with salt and pepper shakers in their hands. Because as you know, some people did die, and some expeditions did have cannibalism. And he read about those before he went. And then that is the Barclay Grow. So in the diary entry, he writes about the plane, and he got an award for helping to secure the lines and protect the ship, because it's very dangerous to do what they were doing in terms of flying. So this is one of the ways that brought Ted and I together, is when we realized that the Walgreen coasts that Byrd mapped and discovered had Thwaites Glacier. And we started realizing that we had more connection than we thought. But they built 2 bases, the west base, I have a picture of, and the east base. And then you can see the track of the Bear with the arrows there along the top of the map. And 2 ships. The North Star was the other ship besides the Bear, but 80 dogs. And of course, you know, dogs are illegal on the ice. And catching penguins are also illegal, but they did that as well. They shot seal, and they caught penguins for the Smithsonian and for food for the dogs and for themselves. So this is Little America 3, and you know, you probably know that Byrd learned a lot about carbon monoxide in his second expedition. So this is well ventilated, but you go down under into the ice. So my father's job, part of that was to help prepare the bases and dig things out and make sure the tunnels were there and get to the kitchen. You could get to the dog tunnel. You could get to the ice palace. I didn't get to tell the 4th graders this today, so I can say in 4th grade, my favorite story was, how do you go to the toilet in Antarctica? Well, they went to the ice palace, and they got stuck. And they took hot water bottles in order to lodge themselves from the ice palace. I got this flag from Richardson's files, mostly to save it from mildew. And then this is the east base, and Ted took this picture. This is a museum now. The west base floated away, but the east base is there. So the west base would look similar without the snow. So you can imagine this base with snow, and then the tunnels to get to the different parts. This is another connection that Ted and I have. But I first want to say that in the research, I couldn't find a lot about this expedition. All the books, all the libraries, even Byrd Polar Library had a little bit, the Library of Congress. And at first I thought, well, maybe it was racism that I couldn't find his picture. I found out later interviewing the nephew of Colombo, one of the people that went on the ice, that it was a secret mission. And it was classified because it was right before World War II. So I couldn't understand why in some of the diaries they were joking about why they were on the ship doing this. They didn't even know the vision and the mission, which is number one, right? Number one for leaders is, what are we doing and why are we doing it? And they didn't know, and they were guessing. So it was declassified probably, well, within the last 20 years, maybe even the last 15 years, it was declassified. So I found that out he was an ex-CIA agent. So part of what happened was, during my research, then everything was in black and white, all the photos. And then, eventually on the internet there was more and more, and I couldn't believe that these machines were red, and the clothing was red. It was just kind of a shock. If you've seen the movie Pleasantville, where it starts off black and white, and then about halfway through the movie is in color. So that was what I felt like. The snow cruiser was supposed to be the third base, and they were going to drive to the South Pole. So when growing up, I always talked about my father talked about the expedition as the South Pole expedition, because that's what they were going to do. And they were trying to find magnetic South Pole, which they came within about 200 miles of magnetic South Pole. Anyway, do you want to say anything about the snow cruiser? That it was amazing. It was about, in 1939, about $100,000. They drove it from Ohio to Boston, ticker tape parade, very slow. They backed up traffic for miles. People were upset. And they got it to Antarctica, and the planks broke as they were coming off the ship. But the real horrible thing was it didn't work. It never went anywhere. And part of it was the tires were bald. Bald tires in Antarctica. Anything else?
What about the plane? What about?
Oh, I don't.
You can do it. Okay. Okay, so the other part of this, if you're going to go to the South Pole, you're going to have to cross a lot of really rugged, crevassed areas. And Byrd realized that you're going to have aerial photographs or at least an observer. And the idea was, they never actually put this together, but the plan was that this plane would be winched up to the back of the vehicle, and then whenever they got to a point where they thought things were dicey and they needed to take a look ahead, they'd slide the plane off, go fly ahead and survey it, and then plan a route from that. There were postcards inside the vehicle of the snow cruiser at the South Pole that they were intending to frank and mail, basically, from the South Pole, partly as a money-making prospect for the expedition, but there are some of these postcards circulating online now. I forgot what I was going to say. It holds about 5 people. There's a bunk room in there. There's a machine room in there. It was an amazing piece of equipment. And if any of you ever remember the Tom Swift series, Tom Swift and the Flying Lab, this is straight out of those books. It's a total come to life kind of science fiction from the 1930s and 40s. Okay.
I was going to say one more thing. I don't remember. Oh, well, the next picture is him standing by the snow cruiser, almost. But this is the expedition. So we're talking about science. Byrd was very much into making sure every piece of science that they could do in Antarctica, they did. So he was known for protecting the science. It was successful. No one died. They discovered mountain ranges. I already told you about this. And 60 people wintered over. So that was the other really cool thing about the expedition, is that my father befriended everyone because he had the food. And helped build the bases and make it comfortable. So he was able to go and watch movies with the ice party. He was able to drive the dog sled. He helped somebody get out of a crevasse. I mean, he was the go-to person and made himself very accessible and helpful. So that's a famous picture, and of course, I had seen that but had no idea what the snow cruiser looked like for years. That's the mascot of the Bear, and then not only did he write every day for 6 months, which I have tried, which is very tough, he had autographs of many of the people on the ship. So that's Byrd. Best wishes to the person who made us our lives more comfortable and pleasant. I also found out he was a great photographer. I had no idea. He took this photo of Admiral Byrd. Yeah. One of his friends doing the dog sled, a seal about to be shot, one of the, and the bear being stuck. Oh, I know what it was going to say about the plane, is that they used the plane to discover where they could go so they wouldn't be stuck in the ice. That was very important. And someone said, Manuel is from Chile. I spent a lot of time in Chile trying to understand where the ship went, where the Bear went. And it was impactful for me because there was a diary entry saying, you know, this is during Jim Crow. People are used to being segregated. And so they weren't. And they were invited to the admiral's parties on the beaches. They hung out with Chilean officers. They did all the things that they would not have been able to do in the United States. And that's another reason why we had such an amazing upbringing. So he was an older father. He was the same age as my grandmother on my maternal side. So we looked up to him, and he was fun, but we didn't listen to all his stories because he seemed like, well, why'd you do that? Why is that important? So I learned a lot after he passed away, and the way that he partied with officers was very important for leadership. I wonder, has anybody ever seen this? It's a message bag. I've shown this to hundreds of people now. Many of them have gone to Antarctica and no one's ever seen it. So it is a bag where there is carbon paper and a pencil and a piece of lead in the bag. And if you are going to get stuck in the ice or something happened to you or you want to warn somebody, you put your message in the snow, and the flag, the orange part, will wave and signal to someone. And of course, he had the autograph of Richard Black. Richard Black was the officer on the East Base. Another important part of the story is I read 3 or 4 diaries, and none of the white explorers said anything about meeting people of color. They met the Maoris when they went on the second round trip, because they went through the New Zealand the second time and the first time Panama Canal. So they met the Chilean Native Americans. And they came aboard and asked for food. And so they were hoisted up and brought to the ship. And it was an amazing photo shoot. I've now seen this photo from different angles. And he was just so happy to meet the native peoples from Chile who are not to this day treated very well. And he writes in his diary or one note about signing his name with an X because he didn't speak English. And then we're going to wrap this part up because there's a lot of science also to share. But I'll just remind you that our artists were aboard almost every expedition from the beginning. First, because there weren't cameras, and then the second time, just because it's so beautiful there that you want to paint and give people the idea of what it looks like. even if you have a camera, you can't really capture the sublime colors. I saw the drawings Wilson did on the expedition, and they were just, the colors were amazing. So this is Curtis and Leland Curtis from Denver. Of course, he'd long passed away when I figured out all this. But his autographs, I went to California to run down Laguna Beach to run down this original painting, which was very, very beautiful. So my work has taken me everywhere to try to piece this story together. So let's do a little science now. He's not going to give me the mic for a while.
Thanks, Leilani. That's always a fun story and really interesting. Well, this is Thwaites Glacier. This is the same area that Barclay Grow aircraft flew over, took pictures of in 1940 with George Gibbs on board the ship. Later on in 1947, it was mapped in more detail by Operation High Jump. And we began to see that this area actually was a critical part of Antarctica. Starting around as early as the early 1980s, it was recognized as an area that could explain massive ice loss in past warm periods between glacier periods. And in fact, a professor named Terry Hughes from the University of Maine called it the weak underbelly of the West Antarctic ice sheet. You can see here, this is really just a small part of Thwaites. This is the fastest flowing area right in this central part here. But in fact, it extends all the way to the horizon. It's the widest glacier on Earth. And it extends over your shoulder out of the page an equal distance in the other direction, about 120 kilometers wide, about 70 miles wide of faster flow. I said maybe I didn't say that yet, about the size of Georgia. Bigger, actually, but shaped a bit like Georgia, where you have a wide coastline and then it reaches well into the continent and can drain the ice from the interior of the continent. This is a map of elevation change taken from satellites that measure the elevation. They've done it twice, and comparing those two, the red areas show the areas that are deflating. Some people use the word collapse. I think that gives the public the wrong idea. It's sort of deflating slowly. And still, it's contributing about 150 billion tons of ice to the ocean every year. But this massive red area here is Thwaites Glacier and its adjacent glacier, Pine Island. Thwaites has a bigger reach into this massive ice. Let's see if we can go back. Yep. Into this area of ice, which is the sort of center part of West Antarctica. So if you take a look at Antarctica, again, sort of a space view, although this isn't a satellite picture, it's a rendition of a satellite map. You can see that Thwaites Glacier occupies this central area of West Antarctica. And if you remove the ice, what you can see is that Thwaites is overlying some very deep canyon areas. And in fact, there isn't a big ridge that's holding it back from flowing into the ocean. So as it flows faster and begins to thin, as it steps back, the bedrock underneath it drops away below it. So you get thicker and thicker ice. You can have the glacier flow faster and faster because that ice is thicker, and that would make it thin faster. So you can get a runaway situation where this one glacier can unload the whole central part of West Antarctica and probably in the process, late in the game, entrain some of these other areas that aren't currently draining into Thwaites, but because Thwaites will be deflating, it will pull this ice in from adjacent areas. Here's a radar movie, basically. A bunch of satellite pictures have been strung together as a movie, and you can see this glacier is literally coming apart before our eyes. This area here is sort of stable. That's the ice shelf. I spent quite a bit of time on this area setting up instruments. We had a whole team. You'll see a little bit of that. This area here is the fastest flowing section that I showed you before from that picture from the airplane. But it goes further down this way and also faster flow up this way. It's quite wide. This is just, again, the central section. So why are these areas losing ice so fast? What's happening? How is global warming or climate change affecting the continent in this way? Well, because the rest of the world is getting warmer, and in particular the tropical areas, there's a westerly wind. It's always been there. There's a westerly wind that encircles Antarctica, but it's getting faster. It's increasing in speed. And what happens in Antarctica is that when you push on something, at least in a climate sense or a weather sense, the Coriolis force wants to push it to the left. So if you have winds blowing this way over the surface, the ocean water on the surface here is going to want to push outward and away from the continent. But that water has to be replaced, and the way you do that is to bring water in from outside at depth. So it comes up from deep within the ocean and then up onto the continental shelf, and it winds up getting close to the continent in a few places, but especially this area, Pine Island Bay or the Walgreen Coast or the Thwaites Glacier. All of those are converging right there. So this deeper, warmer seawater at depth, it was always there. It is getting warmer because of global warming, but it's not supposed to be up against the continent. But because of those winds around the continent, we're seeing them increase, and therefore we're seeing the surface water push away and the deeper water come up. I'll show you another version of this that's a little bit more accurate in terms of what's going on. Well, the problem is that if Thwaites really lets go in this runaway process that I described, which is actually called, you might see this in the media sometimes, marine ice sheet instability. It's an ice sheet that's resting on bedrock that usually or would be in a warm period an ocean seabed, and it's very deep below sea level. That's how you get this runaway faster flow. If you start to push Thwaites, melt the underside of Thwaites, and from that you can get this very rapid sea level rise, this extra high curve from the sea level rise rates that were forecast by the Intergovernmental Panel on Climate Change, the UN group that produces these reports about every 5 or 6 years on the state of global warming on Earth. This was the chart from their last report showing that basically what they're talking about here, this high impact storyline, that has to do with Thwaites in West Antarctica contributing up to 1 meter before the year 2100. This was all before the Thwaites project got started, and it's a major reason why we got started on it. What's more is rapid sea level at these rates of meters per century have happened in the past, and this is a chart of past sea level rise. So this is the entire period since agriculture was discovered. Right about in here, that's agriculture being invented. Right about in here, that's Egypt and all the pyramids and early China and India. Very, very stable sea level. We have not seen what the Earth can do when it's losing an ice sheet, but it has happened before in this period here where we saw rates of 40 to 60 millimeters per year. Right now, the rate of sea level rise is about 4 millimeters per year. So when you're in the process of rapidly losing an ice sheet, you can get this tremendous acceleration in the rate of sea level rise. So we started to make the case to go out to Thwaites with a very large project, hundreds of scientists, and there were several papers in 2014, 2016 that came out that really made the case. Those are quite a few citations. If you look at the citation numbers for those, and that's actually a few years old, there's a lot more now. Basically, these papers were sort of the foundation of why we decided to try to do this. There were several reports written for the various governments. First in the US, the National Academy released this report. I was part of the group that wrote that. This is from the Royal Society in England. So we both nations basically said this is the most important place we can study in terms of forecasting sea level rise. And then this paper here really summarized our interest in going there just before the project was finalized. And eventually we did get about $50 million from NSF and the UK group, NERC, that does the same kind of funding in the UK. And we also, because we had launched this project and because other scientists around the world knew that it was important, South Korea, Sweden, and Germany all contributed significant people and equipment to the project, very international project. It took both the US and the UK, they're probably the two best operating nations in the world for Antarctic logistics, but it took both nations just about everything they had in order to do this, because Thwaites is located on a section of coast that doesn't have any other bases nearby. There's a major base that the UK runs called Rothera, and this one is McMurdo, the biggest US base. It took our aircraft, the LC-130s, which is a unique resource for Antarctic exploration and logistics, their Twin Otters, which are these lightweight aircraft that can go just about anywhere on the ice surface. Our ship, the Palmer, the South Korean ship, has visited several times now. They had a traverse that could tow equipment and do science in this vast area of West Antarctica. And there was a huge camp that we reopened in the center of West Antarctica. This was really sort of the airport and the staging area. It was located right about there, and most of our work goes on further downstream. All of those acronyms are the different groups that went out onto Thwaites Glacier to conduct work. So you can see we pretty much covered everything. We had ocean and sediments in the marine geology groups looking for the recent history of the area. What has happened in the past? How has it responded to earlier pushes on climate? And did it recover from those? And in fact, it did at one point, but we're very close to the same level, and it doesn't appear to be slowing down now. We had groups that were looking at this ice shelf area that I showed you in a movie was falling apart pretty rapidly. And we also, in these different colors, have modeling groups that are using computer programs supposed to study how ice fractures and falls apart, cleverly named dominoes, and Prophet, also fairly clever, trying to forecast the future of what's going to happen in the West Antarctic. We'll see some results from Prophet, and we'll see some of what Dominoes was looking for in just a moment. So this graphic was actually done before we started on the project, but it summarizes how complicated this whole system is. You've got ice coming off the continent here, flowing out over the ocean. It's a thick plate called an ice shelf. We wanted to really take a look at this area underneath the ice shelf, try to get a look at this area here where it first goes afloat, so-called grounding line or grounding zone, where the ice actually lifts off the seabed and water circulates in that area. It's very important for the retreat. We also wanted to measure the ocean much better out in this area. And then we put many, many instruments on the surface of the ice to understand the weather, understand how fast it's moving. We collected rock samples to tell us when the last time some of these rock outcrops, they're called nunataks, were covered by ice. And really trying to cover the waterfront. It was a huge expedition, and really every single group was fairly successful. It took a long time, especially because of COVID, but also because this was a lot for, NSF and British Antarctic Survey really had all they could do to try to support all of these groups trying to be on the ice at the same time. It was extended for several years because of the trouble in getting to these places. Those are the same acronyms sort of located in the places that they were studying. Thor looked at the sediments, and Dominoes is studying the calving at the front. These two are interested in the ocean underneath the ice shelf and also how fast the ice is flowing and coming apart on the surface. This was interested in measuring the rock outcrops. I think that's called geologic constraints. I forgot what the H stands for. And then Time and Ghost were also interested in how the ice is deforming and what the bedrock looks like underneath the ice. In the long-term future, these two projects, their results will be really important for forecasting exactly how this glacier will come off the ice sheet. So here's a typical camp. We had 4 or 5 of these on the ice at certain times during the expedition. This is a pretty beautiful day. We also have some of these tents, Scott tents, same basic design that Scott used on his expedition. We had a few mountain tents also, some larger tents, one for science, mostly a lot of equipment storage in here, and another one for cooking and eating and discussing the plans for during the work. We're on an ice shelf here, so we're sitting on about 1,000 feet of ice and then another 1,500 feet of ocean underneath us. That's flowing out in the direction you're looking at about a kilometer, about half a mile per year. But not every day was beautiful down there. Oh, we don't have the sound on, or maybe I'm hogging the sound, that's the problem. But basically, it's rattling the heck out of that tent, and someone is trying to sleep in there. There we go. Or is that just the guy that he's making up the sound? Well done. Anyway, so it wasn't always nice. We decided not to work on this day, just a little bit too windy, a little bit less wind, and we would go out and work because we have to. We'll only be out there for a few weeks at a time, and there's really a hard end to the season at the end of January, early February at the very latest. You have to come in because McMurdo is very reluctant to leave anybody out through the month of February, just in case there's a storm that lasts for 2 or 3 weeks, and really serious conditions by the end of February would be a problem. So I'm going to show this movie again because it nicely summarizes the 3 problems that we are seeing in Thwaites and what might happen in the future. So this box, you can see that blue box right there in this map of Antarctica. That's the area we're talking about. A little bit closer up view here. And we'll run this. I think it loops. So this area up here at the top is the ice shelf, and it's slowly pushing out. And if you look right before your eyes, you can see these cracks forming. And the thinking is that when this ice shelf goes, when it finally breaks apart and calves off as a big iceberg, this area here could flow as fast as the central area. I'm going to back up. I'm going to go forward again so we can see it. So the concern is that this area is going to accelerate. Now, in fact, the modeling shows that that's not likely to happen, at least not right away. That, in fact, you can tell by how the ice is tearing away from the coastline here. Both observations and modeling suggest that, in fact, there's rocks, basically mountains underneath the ice that are holding the ice back a little bit. But the ocean underneath this will start to circulate faster in this area, so there might be more erosion beneath the ice. We're kind of concerned about the possibility that that would accelerate this part of the glacier. This area down here shows another process that we are really quite concerned about, and I'll back up again and then go forward. Okay. Oh, we don't need to listen to that. Yeah, okay. So what you can see here is a long cliff face, and if you see these dark blocks breaking away, what's happening is, like dominoes, this cliff of ice is actually toppling over into the sea. And the modeling has shown that when a cliff of ice, about 100 meters, about 300 feet, maybe 350 feet tall, when it reaches that height, it calves catastrophically. And the cliff behind it is probably slightly higher than the one that just calved. Again, you can get into a runaway situation. This was actually a big concern in a paper in 2016, that this kind of process, which we sort of see some indication of in Greenland, in some of the thicker glaciers in Greenland, could be a real runaway situation if this cliff that's calving right here were calving back here where the ice is more like 1,200 meters thick, 3,600 feet, 4,000 feet thick. Those sort of cliff heights would be really catastrophic in terms of rapid calving. So this particular calving is not extreme. Now we're going to talk about this because actually Mr. Connor, Connor talked about the ocean getting in underneath the ice sheet and lubricating it, and this actually is a process that we're able to identify from both satellites and submersibles that has us really concerned about the future. And this is the one probably process that is most concerning as we come out of this first 5-year, 6-year project called the International Thwaites Glacier Project, is the potential for this seawater to be tidally pumped underneath the ice sheet, bring that heat. Even though it's a thin layer, all of the heat that's in that layer is completely expended on the underside of the ice, melting it and causing it to thin more rapidly. These other two things turned out to be a little bit less concern than we had at first. We have to wait for this ocean water maybe to accelerate retreat here after this shelf goes away. We think that'll happen within 4 or 5 years, really. It's really on the brink of drifting away. And then this ice cliff process turned out to be, well, you'll see in a second, a little bit hard to sustain the way it had modeled initially. I want to talk a little bit more about how you get ocean water up there, because we're going to go through some of the results of ITGC, and I'll try to make this quick because we still have some more to hear from Leilani. But basically, I talked about that westerly wind blowing and pushing water in this direction. There are also those winds that were affecting the tent that you saw, are so-called polar easterlies. When you get really close to the pole, the wind comes out of the east, off of the continent, and it turns left and is blowing across the tent. Oh, the tent was right over here. Well, when those two things get together and the boundary between them happens to lie over this continental shelf, which is happening because we've pushed these westerly winds further south as they're accelerating due to climate warming. When you put that boundary over this edge, you bring water up from the deep ocean, which is warm, has about a degree or two above the freezing point. You wouldn't want to go swimming in it, but by polar standards, that is really warm water. It comes down through these channels and reaches the very front of Thwaites Glacier. So one of the first things we did was generate a fantastic map of the bathymetry below the ocean leading right up to Thwaites Glacier, right in this area. This is the other big one I mentioned, Pine Island. This is a compilation. We didn't do all of this in ITGC, but we put together quite a few patches in some key areas around Thwaites, creating a better map of exactly how the water gets to the ice. We also measured the ocean flow in the area and proved that indeed that's how this warm water is getting to the ice in one of the first cruise expeditions that we did in this area. This was work by the Swedish team led by Anna Wallin. And then we took a closer look at this ice cliff process. Now this is modeling, but we also had some observational work on that ice cliff in Thwaites and some other areas. I mentioned Greenland. There's also an area in the Antarctic Peninsula that has these tall cliffs. And we've got a little model of what's going on. These are 3 different scenarios that they experimented with. I'll show you 2 of them. So here you've got ice that's not quite as thick as Thwaites, and it's not sitting up to its neck in water quite so much. And the way it breaks apart is like that. These colors indicate shearing in the ice. So it breaks apart when you get up to the green and the yellow color, basically, in the model. And then this other one is a lot more like Thwaites. And that's a more complicated situation where the top part falls into the ocean and then it lifts the bottom part off because there's no weight. The ice is nearly afloat. If you take anything off the top, this front edge wants to come floating upward, and then it breaks away a big chunk and drifts away. Those things are real. They happen. The problem is that you have to feed the front of this glacier at just the right speed, and you have to have the right thickness and water level. All of those things are sort of a careful balance. The other issue, which you might be able to imagine better from this one, is that the front of this ice cliff that's calving can get pretty clogged up with other ice that's just calved, and that slows down the process by bracing the cliff. So we think that this ice cliff process may be a part of the retreat, but not right away. Maybe in the next 50 years or so, this will be a bigger factor. This one down here will be a bigger factor. To get access to the ocean below the floating part, we used a very simple process, a hot water drill. So we take a whole bunch of pumps and heaters, takes a lot of fuel to do this. This is a storage tank for the water. And we drive it through a jet into the ice. And this thing will bore through 1,000 feet of ice in about a day and a half. Now that ice starts to freeze in and flow and tries to close off the hole. So we have to keep running in with this kind of a device. We have about 24 hours of work that we can do using the borehole before we need to run back in and wash it out again with warm water. So yeah, that's a sort of a diagram of the whole process. One of the things we did with the borehole was set a bunch of ocean instruments and a super duper weather station called the Amigos 3, automated meteorology ice geophysics observing system. We set that thing up. It's got a lot of science in there. We measured the snow height, we measured the weather, we sent back the data with Iridium, that's a GPS antenna, we had a camera. And there's a cable down here that you can't see that goes into the ocean below. And this thing worked actually for a couple of years, and we got a tremendous amount of data from that, from one point. But even more exciting, and I guess someone here is working on this project with Brittany Schmidt, we sent a robot through another hole that we drilled called IceFin, which is also loaded with oceanographic instruments and cameras. and actually managed to visit the very point that I mentioned before where the ice first goes afloat off of the continent, and also understand the oceanography in this very complicated area where the ice is fracturing and the water is circulating. What we found was that, in fact, there isn't a lot of melting going on in these flat parts of the ice sheet, that very quickly you develop this cold water layer that just kind of hugs the underside of the ice, and it isolates it from the warm water. So the melting rate is actually slowed down quite a bit in areas like this. Instead, amazingly, what happens is that in all of the steep parts, you start to set up a little circulation system. So the water hits the side of the ice. It melts off a little ice. It's seawater, so with fresh water in it, it gets less dense and it moves up and away and forms this little circulation. And the face, the vertical face or near vertical face, is the point where all the melting happens. The cold water stays flat underneath here, but when you get a little bit of a slope, like that one right there, it doesn't show it being warm, but you'll start to generate a little circulation. And instead of erasing the underside of the ice evenly, like a windshield wiper, this thing will sweep across and take off about 1 meter or 2 of ice over the course of a few years. That's what we've been seeing with satellites. We thought it was even melting underneath, but it's actually isolated little stair steps where all of the melting happens. Now, this is the process that I think still has us quite concerned, and this has to do with tidal pumping at the edge of the ice shelf. So this thing is lifted and lowered about 2 meters at the most during highest high tide, and it actually winds up pumping this water. It's bright red here, even though it's only 1 degree or 2 above freezing, because this is, well, you would say it's 1.5 degrees, 1.8 below freezing because it's salt water. So being 1 to 2 degrees above freezing, 1 to 2 degrees centigrade, means that it has a lot of heat in it. And every day, this ice is lifting off. It's rapidly drawing in 1 meter or 2 of water all the way up 15 kilometers or so underneath the ice sheet. And then when the ice lowers, that cold, freshened water comes shooting out again, and then the process starts again. That actually is extending well underneath Thwaites Glacier. This is what is, I've called it the grounding line. You could call it the coastline of the point where the ice is supposed to be resting on the seabed. But in this area, this tidal pumping process is pushing water many kilometers upstream, and it's a way of getting that heat here up against this ice so that all of the heat that's within it is used up melting the underside of the ice. So you break down that isolating cold water layer that I mentioned before. And I think we're close to the end, but this is actually a model. Let me just stop that for a second. So this area here is Thwaites, and this is Pine Island, and this is another area I haven't mentioned called Dotson. That's basically the core of the West Antarctic, and this is the ocean out here. Now this model runs forward for, I think, 500 years, but I think you'll be able to see when this area starts to turn blue, meaning that there's been a whole lot of elevation loss, that the ice sheet is deflating rapidly, that we're in trouble, that's the turning point. So at first, it's going through at a pretty good clip. Here's 30 years, not a whole lot happening. 50, 60 years, not a whole lot happening. Starting to turn blue here at 80 years, but right at about 120, really it starts to take off, and you can see this inflection point here in the rate of sea level rise that's coming out of this section, and it just gets really bad, but that is 200 to 300 to 400 years away. Still, it's a process that we don't have a means of stopping right now. Once it gets started, it's going to go through to completion. There are people talking about geoengineering. I mean, this is the state of Georgia is just this area right here. So this is a very large area that's being involved in this runaway decrease of the West Antarctic ice sheet thickness, and of course sea level rise up to 45 centimeters, about 1.5 feet as a result. Remember that Greenland is also involved, and all those mountain glaciers are also involved in raising sea level. So in the long run, and possibly, I mean, this model did not include every process, did not include that basal melting process, the pumping process that I just mentioned. So it could happen sooner than that. But we do think that for the immediate future, one of the main goals of ITGC was to understand whether or not we were in trouble of seeing a sudden rise in sea level within the next 20 to 50 years. That seems less likely now, but by the end of this century, there are quite a few of the folks that are in the ITGC group that think that things will start to accelerate rapidly at about that point. Yeah. Leilani is going to take us home, and then we're gonna have question and answer period. I know we probably run long because we both love talking. I'm going to give you that, and I'm even giving you the microphone this time.
Well, I want everybody to just take a breath, a deep breath. I remember when I first saw some of these slides of it melting away, it's emotional. So I just want to give space for that. And as a social scientist, one of the reasons that I'm connected with the Thwaites process and the project is because it's tough to do extreme work, science, in this kind of environment. And it's almost like the continent closes in metaphorically on anyone down there to see, let's just see how tough you are. And one of the things that happens is emotions run high. People are stressed. People are tired. When the weather's good, you work round the clock. So we did a lot of work on asking people, like, what is your stress level? How do you handle stress? You know, what's your style of communication? Do you go in your tent when you don't want to see anyone, you don't want to say anything, or do you want to just keep talking for 24 hours because you have to get it out? And so who's your roommate and what is their style and how do you handle that? And if you're working, you're living and working and breathing with all these people, you either are going to love them at the end or never want to see them again. So we care about the people, we care about the teamwork, we want to build a positive work environment. So each time people went to the ice, we gathered, mostly on Zoom, to have sessions about how do we prepare psychologically, mental health, to work together as best as we can. So this is a model that we built. We wrote a paper about it, and just to see what are the things that we do to build a positive work environment. What does it take? We started with a code of conduct for people who went on the ice, and then from there it was deeper. We talked about leadership, we talked about early career, we talked about what to expect on the ice. A lot of times people go and you just think you'll just figure it out when you get down there. And we decided that that was not the best choice. And then we just wanted to just say a little bit about the yes that we all need to have around the world. So Admiral Byrd started this idea of Antarctica needs to be for future generations. And that's part of the impetus for the treaty. So 12 countries came together in consensus to say we need to save it for peace and science. And now 55 countries at least in 2022. It's not claimed. It is for everybody. And so I want to think about what is the yes that you can say to yourself, to each other, and that what is the collective yes that we need on the planet in order to have Antarctica stay for peace and for science.
And then there's one more yes that we need to get to, and that is a yes about taking care of the planet with regard to climate change. And that's going to take a tremendous effort and really a level of agreement and cooperation that humanity is not used to experiencing. And so that's the last yes, is yes to the planet and yes to trying to solve this issue. And thank you very much for listening. Okay, I don't know if we have a microphone. Oh, we do have a microphone.
Hi.
Hi.
Steve Picard from Queens College,
hi.
and I'm actually a climate scientist. I study the past climate, like Miocene climatic optimum and
Oh, I
stuff like
see, yeah.
that.
Huh?
Yeah, actually, I wrote a paper with DeCanto, for example.
Oh,
you know.
really? Yeah.
Yeah. So anyway, so you think that that it seems I was hearing in the literature that it was going to be accelerated, it was going to get over that hump, over the ridge, and so it's melting further and further back faster. And you're saying that it's probably okay for this century.
Yeah, there it is.
And but you know, like if you look at like James Hansen's papers, he talks about an acceleration of sea level rise that's not linear, but it'll be more exponential over time.
Yes.
Well, what are your thoughts about that?
Well, I do think that the real problem area, I'm looking for a good slide to help back this up, but the real problem area is going to be when this grounding line, which you can sort of see, it's basically the point at which these are bottom crevasses, tears on the underside of the ice that show up as a little divot on the surface. When that line gets to some of this really dark area back here where the ice is much, much thicker, that's not why it's dark. It's dark because it's dry snow, but it happens to coincide with where the dark areas are. Then we're going to see quite a bit of acceleration. Right now, that retreat rate is about 1 kilometer or 2 per year. It's about 30 to 50 kilometers back. And so, yeah, I would say that before the end of the century, that you mentioned a ridge, and there's a nickname for it, either Ghost Ridge or Ridge A in the literature, and it's basically high, they're submarine, but they're high hills coming up off the seabed that are resisting the flow of the ice. Part of that is why the ice shelf here, when it goes, is not going to accelerate. There's sort of a ridge area in this area, and then there's more back here. Well, actually, it's further back, about here for Ghost Ridge or Ridge A. And yes, that's going to be a real challenge for the models, and things will pick up speed. Whether or not they'll do the runaway that was imagined by DeCanto and Pollard, in terms of when you add in the ice cliff factor, that's the thing that really took things into a scary territory. And it's not that they were wrong, it's that the pace of that process, it's really hard to sustain it for a long period of time. Yeah, you had a question.
Is there a tipping point, for example, the Greenland ice sheet starts collapsing, and that raises the water, and something else happens in the climate, and maybe everything, and also this is now 2035, you have the wobbling of the moon, and you have the highest tides in the world. Could that accelerate everything?
No doubt it could, and let's see. That tidal pumping is a major factor in terms of getting the heat from the ocean to act upon the underside of the ice sheet. That's going to be a process that hasn't fully been modeled yet that we need to look at more closely. Other tipping points going past that Ghost Ridge that's underneath there, I didn't bring the map that shows it, but is another kind of tipping point. But in fact, some of those papers that I showed that were the underpinning, I said the foundation of why we could get the two nations to agree to send 100 people and $50 million and throw their entire Antarctic program, basically, at least the fieldwork part, at this one project for 6 years. I lost my place. Basically, it's this, it's this runaway process of marine ice sheet instability that we're worried about. That's a tipping. Oh, I'm sorry. Some of those papers were saying we're already at the point where it won't stop. That really it may be slow. It may take a millennium, but we have already reached the point where eventually this ice sheet is going to be gone unless we radically, and I mean radically, change climate, like not just stopping producing CO2 and putting it in the atmosphere, but drawing it back down to a level of basically 1950. Okay, so, well, we can talk later.
Okay, go ahead. Why don't you ask the question?
I think what is most interesting to me is what is a day in the life of somebody on one of these expeditions? It's mostly scientists, yes? How do you take care of the mental health component? Do you have a psychologist with you as part of your team, or? Thank you.
Well, I would say that at Thwaites, in other expeditions, they might have had a psychologist, but we don't. So we talk about how do you mediate between, if you see your colleagues, can you ask someone to help mediate, and what are the mediation skills? And what?
I think most of the folks at ITGC would say that Leilani did a pretty good job of being our psychologist. And I'm not sure if Leilani made it clear, but when we got this group together and we started thinking about DEI issues and having a person that could speak for us about both team social dynamics and DEI issues, I said, I know just who we ought to hire. I'll give you the name. You guys decide. There were a few other candidates. We never regretted hiring Leilani. I knew that she was interested in Antarctica, and also her job is to talk to companies about teamwork and working together better. So it worked out really well. Yeah, psychologists are not common in Antarctica, but they're needed.
And I'm of the ilk that we teach people the skills so they can be better at doing this themselves. So one of the best stories is that two leaders didn't work well together, and they asked a colleague who was very shy about the mediation and did it well. And then you feel empowered for the next time. Yeah. Is there somebody?
How much time have you spent in Antarctica versus your father? How much time have you spent in Antarctica versus your father? And will you go back again?
Ted and I are speaking at a National Geographic cruise during Thanksgiving. I'll be there for 8 days. My first trip for research was a day and a half. And I raised $7,500 to go for a day and a half. And I'll just, quick story is that I didn't want to go. So everyone kept telling me throughout the years, just go. Why do I want to do that? I grew up in Minnesota. I live in Colorado. I know cold. I know ice. Why do I want to do that? And then a friend had a dream that we were with penguins. And so I like signs, and that was a clear sign. And now I understand it is different. It is different once you go and see it. All of his diary entries made sense. So that's why I'm going back now.
Thank you both for an excellent and informative presentation. Leilani, just from a historical perspective, I was fascinated to see that your father's, visit to this remote part of the world was very much on the eve of World War II. And you mentioned it was classified. And you have these incredibly talented people going out to the most remote regions without knowing really what the objective was. What was it, either from a military standpoint or an intelligence standpoint? Can you fill us in on that? That's so fascinating. Thank you.
So you're asking why they went? Why was it classified? Because they thought they were going to keep an eye on the Germans. What were they up to? And of course, you might know some of the conspiracy theories about they might still be down there, or Hitler might be down there, or there's frozen bases. So yeah, they were looking at what the Germans might be doing down there. And then it turned out, for some reason, they did something else. So I don't know if they got confirmation that the Germans were not messing around, and then they decided to do something else. And the other question you said was how long. They did 2 round trips. They started November 22nd of 1939 and came back June of 1940. Then they went again October of 1940 and returned in June of 1941. And the reason is because Roosevelt said, get back. We're not going to be able to protect you because the war is full on now. It was a harrowing rescue to get them off the ice, that would be to be continued, but that's a whole story in itself of how they rescued the people on the ice. You had it right here too. Right here.
I was wondering if you had a view on just run-of-the-mill tourism to Antarctica. It seems like we're hearing about it more and more. More people are going there. Is it damaging to this very fragile environment?
It's a gamble. It's a mixed bag. Is it damaging? Not particularly, not any more than cruise ships in the Bahamas, and there's a lot of rules about how the cruise ships operate. In fact, one of the big rules was using lighter fuel, which breaks up more easily should there be a spill, which actually caused a lot of ships to be disqualified for doing that touring cruise work. But the trade-off is that the folks that go there, and Leilani kind of touched upon this, is that people really, almost to a person, they fall in love with the place. They're amazed at it. They're bonded to it. And this was true back in the Explorer days. I mean, these guys nearly died, and they get back, and the next thing they want to do is raise money for the next expedition. And it's no problem finding men to try it, and the guys that have been before, most of them want to go back again. No, it's not like it's a mental illness. It's just a very captivating kind of place. It could be a mental illness. I don't know. I've been 23 times, so judge for yourself.
Hi, yes, I had a question. I'm Emily McGlone, Director of Peace Boat US, and our ship is actually going to Antarctica this January, so we passed all the regulations and have all the safety protocols in place. And the Peace Boat is traveling always from Patagonia down to Antarctica. I was just curious, we're doing a lot right now with education for the United Nations Decade of Ocean Science for Sustainable Development, which is now till 2030. And as scientists and researchers, what is something that you would hope every young aspiring scientist would know about Antarctica? Like, if we're taking young leaders to Antarctica, what do you hope that they will gain from that experience that we should share?
What happens in Antarctica doesn't stay in Antarctica.
Well, I have one thought is that the Antarctic Treaty is for mining is up in 2048. And I spoke with first graders in 2012 when I went, and I said, you will be the decision makers when this is happening, and so please understand the continent, how it affects the planet, what the risks are, so that you can help influence that decision and learn how to come to consensus, because the treaty needs consensus in order to stay the way it is. And that's tricky, as you know. We came together as a world once. Can we do it again?
I guess I'd say something more along the lines of climate is changing, and even as far away as Antarctica is, it's responding to what we've done and actually poses a threat in the future for sea level rise. I don't want to scare everybody because it's going to be a very slow-moving catastrophe, but 2 or 3 feet of sea level rise just from Thwaites, and the 2 or 3 meters or close to 10 feet that could come from Antarctica over the course of the complete collapse of the ice sheet, that's a dramatic change for planet Earth, and it's going to be something that will be incredibly hard to adjust to. Stopping it now, we can slow it down now by taking action. That's really important. That would probably be my first message.
Do 1 or 2 more?
I went to Antarctica. You only go to the Antarctic Peninsula. We never got to the Antarctic Circle. It was like winter there. It was like in the 30s. Okay. This past year, I went to as far as we could go towards the North Pole. I was on the Arctic Circle in my shorts. It was very warm. It was like 70 degrees. We went to the very top of the Europe point. That was above the
Nordkap.
Well above the Nordkap.
Yeah.
It was 40 degrees. Why is it so much warmer in the north?
We've been talking about it all night. We've been talking about it all night. Well, it's because of the loss of sea ice over the Arctic in particular. That's especially why Norway and the northern areas of the far North Atlantic are warmer. Barents Sea, which is the sea that you were looking at when you got to Nordkap and looked out on the ocean, that although you went in summertime for sure, but that ocean used to remain ice covered well into summer, and now it was only
totally
a short
open.
period in the winter when it gets any ice cover on the ocean.
We went in the Arctic Ocean, and it was totally open.
Yeah.
But it's so much warmer. I
Yeah.
mean, it's like
Yeah, no, nobody who lives in the
above
far
the
north
Arctic
doubts
Circle.
that global warming is happening. That discussion is for us here in America, where we're away from the cutting edge of it. Folks in Alaska, they know that it's different. The Inuit, they know that things are very different. They can't hunt or store meat the way they used to. The seasons are all different.
Is it the Gulf Stream too?
Pardon me?
Is it the Gulf Stream as well that's doing this?
Yes, in a way, but the biggest, it has an effect on the ocean in the Arctic, but the biggest effect is warmer air temperatures causing that thin layer, it's only a few feet thick, of ice that covers the Arctic Ocean to disappear, to retreat. It's about 40% of what it was back in 1950, 1960.
All right, my question is for Dr. Scambos. It's whether you've considered the negative feedbacks in your research. I'm thinking of the glacial rebound and also the weaker gravitational effect and how that might slow down the retreat of Thwaites.
Yeah, the weaker gravitational effect is more for how sea level rise will be distributed. And in fact, it's almost ironic that the areas that will lose ice, like Greenland and this area around Thwaites and Antarctica, will actually see sea level drop near them because you're losing so many billions of tons from the ice sheet that the gravitational field of the Earth, basically that mass, billions of tons, isn't there anymore to pull the ocean close to the coast. It's gone into the ocean, and so the ocean isn't pulled quite as strongly to the coast in that area. But you said something else, and yes, that's right. And that does have a slowing effect. In fact, it's quite extreme. One of the things that was learned, I didn't bring it up, as part of the Thwaites project was how fast that glacial rebound is happening in the areas where ice is lost. The question was, how stiff is the bedrock underneath the ice, especially the mantle? It sounds like you'd be familiar with those terms. And that mantle in Canada is slow enough in responding that Canada is still rebounding slowly from the loss of the giant ice sheet that was over most of Canada in the past. But in Antarctica, the two places where we've really investigated carefully, that mantle, the rock below the crust of the Earth that makes up a huge, thick section of the Earth, is much warmer, and it responds much more quickly. So it is a factor. It's a mitigating factor, but it's not enough to stop the retreat completely. That has been modeled. Okay. Any more questions, or are we ready to drink?
Okay. So, Leilani Henry and Dr. Ted Scambos, I want to thank you so much. Your work. This is an example of the kind of science, the kind of field science that can save humanity. Humankind has to do major planning to deal with the catastrophic effects of these ice sheets melting and moving. And it's the work bit by bit of people like this that risk their lives and give their time. And I think that's so important. And thank you so much for what you do for science.